Okay, in this video we will go over the second sample that the professor gave you for this exam 3. So let's start here. Consider this function. A says consider all the intervals where f is increasing and decreasing. And B says classify those critical points. So the first thing we're going to do is take the first derivative, right? So the first derivative of this thing, so I bring the 3 down, that takes out that 3. 14x squared minus 14x minus 28, right? Well, if I want to set this equal to 0 and find those critical points, I can factor out a 14. This will make our lives easier, right? And since I'm solving, I can divide by this constant. It basically goes away, doesn't it? So this is what we have. And that factors to x minus 2x plus 1. So our solutions are x equals 2 and x equals negative 1. So I like to come over here and make my number line. If this is negative 1 and this is 2, this is where we know that first derivative is 0. So I'm going to test some numbers to figure out where things are increasing and decreasing so I can answer A and also determine whether these are maximum or minimum, right? So let's look at the first derivative, which here we're going to, in this case, it's the first derivative, right? I simplified it. If I plug in 0, this thing's negative, isn't it? If I plug in 3, let's see what I get. So f prime of 0 is negative. F prime of 3 is 9 minus 5. It's positive. Let's take f prime of negative 2. Let's see, that would be 4 minus a minus 2 minus 2, so that's positive, right? So these are positive and positive on these sides. So what we have is a positive slope. That means increasing, right? So when it wants the intervals of increasing, it's from negative infinity up through negative 2. Now I don't remember if he wants an open interval or closed there, right? Then the interval where it's decreasing, not negative 2, negative 1, sorry. It's decreasing from negative 1 to 2. Those are the two critical points. And then it's increasing again from 2 to infinity. All right, so if it's increasing and then decreasing, that makes this thing a maximum, doesn't it? And if it's decreasing and then increasing, that makes this point, this critical point, a minimum. Okay? Now it says find the intervals where f is concave up and those where f is concave down. So we need to use the second derivative, right? I'm going to come over to this page. I have it twice here. My first derivative, again, when I simplified it, I'll just leave it like this for a second. I'm going to go back to this. That was our first derivative. What does our second derivative look like? It looks like 28x minus 14. Let's set that equal to 0 to find our inflection points. Right? 28x equals 14, divide by 28, x equals 1/2. So I have one inflection point. So I'm going to put that here. This is where my second derivative is 0. So let's figure out what intervals were concave up and concave down. I need to test. Here, I can test this at 0 and 1, can I? Those are on either side. 0 makes this negative. If I plug in a 1, 28 minus 14, that makes this positive. So the interval here, minus means concave down. So from negative infinity up through 1/2, again, you double check about that. This is concave down, right? And then from 1/2 to positive infinity, it's concave up. All right, that one's pretty basic. Let's look at this next one. This one was a little crazy. All right. And I hope he did something like this in class, but find the tangent line approximation. So the tangent line approximation, let's go back to the basic equation. Tangent line approximation is approximately equal to f at A plus f prime at A, whatever you're doing it near, x minus A. So they want us